Let's talk about binomial distribution, and I believe last year we have talked about that as well. No, but I believe we did. Yes, probably. Okay. Just talk about what is it. So first of all, we talk about what is called a Bernoulli sequence. So a Bernoulli sequence is the name to describe a sequence of repeated trials following the follow properties. Okay, so we have a Bernoulli sequence. First of all, we need to understand what is a Bernoulli sequence. So it's a sequence of repeated trials. So they need to satisfy what? The experiment contains a number of identical trials. So I need to keep repeating doing something. Okay, I'm keep repeating. So for example, if I'm trying to observe whether sunny or rainy for each day, so I'm keep observing for maybe 30 days, so that's n trials. The second thing is each trial results in one of the two outcomes, which are usually given as success or a failure. So there's only two outcomes from my trial, so success or not success, or success or failure. So for example, if I can say, well, if I observe whether it's rainy or sunny tomorrow, so if it's sunny, I can say it's success. If it's not sunny, I can say that's a failure. So I can still change the result to success or not success. Or another example can be, if I have 3 color ball in a box, I have blue, white, or black, 3 color ball in the box, and I can randomly pick one. Well, I can have 3 different outcomes, right? I can have blue, white, black. But if I say I only want white ball, so I treat white ball as a success, and all the other color I can say this is a failure. So that still satisfy outcome yes or outcome no. Like still can give it like success or not success. And the third one is important. The probability of success on single trial P is constant for all the trials. So the probability to be success on each time must be the same. So this must be a with replacement question. Okay, it must be a with replacement question. It can't be without replacement. If I say there's white chocolate and black chocolate in the box, I want to withdraw chocolate from the box, I can't withdraw one and eat one. If I eat it, that disappeared, and then the second time you withdraw, it depends on your first outcome. Like it's not independent, and also the probability will change. So if you have 5 and 5 at each time, then you take a white one, it become 4 and 5. Then the probability become 4 and 9, not a half anymore. So the probability will change if you don't replace the first withdrawal. So it must be a with replacement question. This can make sure all the single trial have the same successful rate. Well, say observe the weather for tomorrow. It's not going to be the same as the situation because the chance to be sunny tomorrow is all different on each day. So you can't say it's really a half. It's not really a half. And also the weather depends on what your previous day's weather is. If it's rainy today, it's more likely to keep raining for tomorrow. Sunny today, maybe keep sunny for tomorrow. So it's not really independent. It's not the same probability for each day. So it's not satisfied Bernoulli sequence. So withdrawal problem normally can be a Bernoulli sequence, but you need to replace the thing back. And then the last one must satisfy all the trials are independent. So same as if you do a without replacement question, then all the trials are not independent, like depends on the previous outcomes. So when you do your tree diagram, you'll see, okay, the white one, and then I will take the white out and reduce by 1. So in this, if you have situations satisfy all of this, this will become a Bernoulli sequence. Okay, this will become a Bernoulli sequence. So the number of success, or like if I do something n times, how many times I can get success? I can get 0 times success, 1 time success, 2 times success, until like n times success. That's all possible, right? This is my random variable x. Okay, this is my random variable x. My x can be what? Can be 0, can be 1, can be 2, can be until n. That's n success, 0 success to n success. So the number of success is a binomial random variable. Okay, like like we have normal random variable, like all the x we learned last week, they are random variables. I have x can be this value, this value, this value with this probability, this probability, this probability. But now there's a special name for this random variable. So the number of success in such event, we can call that as a binomial random variable. Okay, we can call that a binomial random variable. And we're no longer using tables to represent the probability. Okay, we no longer use tables to represent the probability. What we're trying to do is each probability will follow a formula. This formula is called a binomial probability distribution. Okay, you know what's distribution? Distribution is how probability is given to each values. So we have a special function. This is the function type. Okay, give you a mass function. Like px equals to what, and when x equals to 0, x equals to 1, x equals to 2, you sub different x values and you will get different probability. So this is a function question. Okay, so graph, function, table, like this is a function one. It's still a discrete random variable because your x can only take 0 to n and all the integers between that, right? All the integers. Okay, so now there are two things important, very important for when you're doing questions. First of all, you need to define random variable. Okay, obvious random variable. So first of all, you need to define your random variable. So it's normally let x be the number of success in the event. Okay, it's normally, well, you won't say let x be the number of success. So for example, if it's a shooting target question, if I'm trying to shoot something, if I have 0.7 to shoot the target, so I can shoot 10 times, and the x will be let the x be the number of times I can actually shoot the target. Like I have 0.7 of the chance to shoot the target, but like let x be the number of times in that 10 times I can actually shoot the target. So this is means define let x be the number of success. Well, different situations you have different way to define as success. So just describe it here. So if there's no x given in the question, you need to define it first before you use it. Okay. Second is when you read the question, you realize that is a normal question, binomial question. You realize, okay, this belongs to a binomial distribution. This is a Bernoulli sequence. Then I will write x is binomially distributed. Okay, BI, binomially distributed. So a binomial distribution will influenced by two things. Like I would say this is two parameters. Decide, like if I'm talking about probability x equals to 3, means I want 3 success. Okay, in two different situations, if I can shoot the target with 0.7, success 0.7, you can shoot with 0.8, and we all do 10 times. The probability for both of us can achieve 3 times will be different, right? Like it will influence by the successful rate each time. Okay, if I can shoot each time with 0.7 accuracy, you can do 0.8 accuracy. So we all do 10 times. I can shoot 3 times and you can shoot 3 times will be different. Okay, will be different. So the probability will influence by each time the successful rate P. The second thing is if we all have accuracy of 0.7, but I shoot 10 times, you shoot 20 times, the probability I can get 3 and you can get 3 will be different. So the number of trials, how many times you actually do it, will be another factor influencing the probability. So P and N, like I will write N comma P, is how we define a binomial distribution. So when you realize it's a binomial distribution, you need to define it and you say this is a binomial distribution. Okay, the next thing, okay, remember the 6 things we talk about. First of all, we talk about the probability where x is what, equals to what, greater than what, larger than, smaller than what. We talk about probabilities. The second thing, we talk about expect values. We talk about median, we talk about mode, we talk about variance, and we talk about standard deviation. So the first thing in binomial question is how we calculate the probability. Okay, how we calculate each time the probability. What's the mass function given? Okay, what's the mass function given? Okay, this is the mass function, and that is something you must remember. Okay, this is a mass function formula. It's looks like a very complex one, but it's very easy to understand. Let's do let's say an example. we have a bias coin. Okay, we can have a third of the chance to get a head and 2/3 of the chance to get tails. Okay, it's a bias coin. I toss it for 3 times, and I want to observe the number of successes, the head, how many head I can achieve. Okay, is that a Bernoulli sequence? Is it a Bernoulli sequence? Yes or no? Toss the coin 3 times. Each time success rate will be a third. I'm trying to observe how many heads I have as success. So it is a Bernoulli sequence. Independent, repeating, all the probability the same, so satisfy Bernoulli sequence. So let X be the number of success for head, like how many head I can achieve. So now I'm trying to binomially distribute, X is binomially distributed with 3 times, and success rate will be a third. Okay, that's what we'll have. Okay, let's not think about binomial or something like this. I just said toss the coin for 3 times. I want 1 head as the result. How many different cases I can have this? I can have head, tail, tail, right? I can have 1 head in this situation. What else I can have? Yeah, tail, head, tail. What else? Tail, tail, head. Is there anything else I can have? 1 head? 1 head. No more. Okay, head in first place, second place, and third place. Okay, just look at this situation. What's the probability I can get head, tail, tail? What's the probability I can get a head, a tail, and a tail, then a tail? Like a head first, a tail, and then a tail. What's the probability? Oh, it's a bias coin. The probability I can get a head is a third. I can get a tail is 2/3. A third times 2/3 times 2/3. Okay, what's the probability to get the next probability? Like 2/3, 1/3, 2/3. Okay, how about last one? 2/3, 2/3, and 1/3, right? They're all the same. Like for each of that, I can get 1 head. 1 head doesn't matter where's the head. I will get exactly the same probability. So overall, I achieve 1 success and 2 failure, right? 1 success and 2 failure. So for all of this, I can represent as a third to the power of 1 times 1 minus a third, which is the failure rate, which is 2/3, to the power of 3 minus 1, right? Is 3 in total. I have 1 success. I know there will be 2 and success. So it's 3 minus 1. How many do we have here? 3. So I need to times the 3 as well, right? To have 1 overall, to have 1 head. So that plus that plus that, because they're all the same. So I have a 3 in front. Okay, then let's go back to see what the formula really represents. This formula said I want X to have X success. Okay, X times success. I have N times in total. I want X success. So look at here. P to the power of X is the success. You know, if how many success you have P times P times P times P until you times XP here, right? So it's P to the power of X. 1 minus P is the failure rate to the power of how many times you have been failed. Okay, it's the failure times. What's this in front? It's like the 3 we have here. Is NCR is how many situations, how many outcomes we can have this many success. You know, like say we have 1 success. This success can be at the first place, second place, or third place. You have 2 success. The 2 success can be first and second, second and third, third and fourth, or second and fourth. Like you can have different places to put this 2 success. So this NCX thing is to tell you how many combinations, how many ways we can have different success at different places. No, I can have X number of success in different places. So that's the number, how many. And then in each time, I can have P success to the power of X and 1 minus P failure to the failure times. That's exactly what each individual of that gives you. Okay, so that's the formula, the mass function for the number of success, how to calculate 1 success, 2 success, 0 success, and so on. And the NCR formula is given again here, n factorial over x factorial over n minus x factorial. Okay, this formula is useful. You need to remember that, but it's not that useful because most of the things we'll do by calculator. Okay, most of the things we'll do by calculator. So you need to remember the formula, yes, because we'll use it later, but also calculator is very important for this question. Okay, let's have a look at example 1. Let's have a look at example 1. Example 1 says, a survey shows that 60% of students play in a sport team. If a random sample of 10 students are asked if they are a member of a sport team, find the probability that, okay, let's finish reading here. Okay, survey shows 60% of the students will play in a sport team. If a random sample of 10 students are asked if they are a member of a sport team, do you think this is a binomial question? Yes, yes, because if 0.6 of the students play in a sport team, I pick any student and I ask you, are you playing sport? There will be 0.6 answer me yes and 0.4 answer me no. And your answer doesn't influence the second student's answer because they are all independent. Okay, they're all independent. So this is actually a binomial question. So if it's a binomial question, we need to define the number of success. Okay, what's the number of success in this question? How I should describe? What do you recognize as a success? Number of students. What else? Number of students in a sports team. Good. Let X be the number of students in the sport team. Okay, X can be 0 to 10. I can have no student in a sport team and 10 students in a sport team. So also you know X is binomially distributed with 10 students, 10 questions, 10 students with 0.6 of the successful rate. You can answer 0.6 yes, 0.4 no. And if it's a binomial question, you must say it's a binomial. Okay, you must define X as a binomial. Otherwise, you can't use formula for binomial unless you say it's a binomial distribution. Otherwise, how you can directly start using calculator and put numbers in, like what you use for. So you need to define it. Okay, the first question asks you exactly 3 students in the sport team. So what I'll do is probability X equals to 3. There are 3 students in a sport team. I want 3 success. Then just doing the formula. NCR, I have 10, I need to select 3. This is how many ways I can have 3 be placed in different spots. There are 10 spots, I want to put 3 in different spots. And then I can have 0.6 of the successful rate that will to the power of success time. And also I can have the failure rate. Okay, there are 3 success, then we'll have 7 not in the sport team. So it will be the 0.4 to the power of 7. And what you can realize here is, even though I can use the formula, it's still not possible to calculate it, right? Like how I can calculate it. Too large, like 4 to the power of 7, 6 to the power of 3, and then there's the NC3. Like it's very hard to calculate. So most of the things, like this formula is not used for doing this, okay? So when we ask probability, is you normally 99% of time you use a calculator to do it. So if you go menu, number 5, and okay, if you go down, well, if you calculate has been updated, you should have A, B, C, D as what I have here. If it's not updated, I think it's E for the not updated question. But if your one is updated, you should have A as binomial PDF, B as binomial CDF, C as inverse normal, and D is inverse normal N. Okay, which ones we'll use is A, B, and D. Okay, we're not doing D today. D is next lesson. So we're doing A and B. Okay, what's the PDF means? PDF is asking for find a value, like a single X equals to something. For example, X equals to 2, X equals to 3, X is 5. We use PDF. CDF is a continuous value. when x is greater than 3, when x is less than 5, when x is in between 3 and 5. So we use the CDF. That's the difference between a PDF and a CDF. So in this case, we want x is 3, so we choose the PDF. So the PDF gives me 10 trials, and success is 0.6. So we type 0.6 here, and x value is 3 in this case. Okay, type that in and press enter. The question, is the formula already stored in the calculator, and when you type all the information, it will insert into the formula directly for you, so you can use this probability directly. Let's say that's 4 decimal places. Give 4 dp for all the questions. Normally, by probability is given to 4 decimals, but you need to read the question. So let's say 0.0425. Okay, that's the probability. The next one is asking at least half played in a sport team. Okay, at least half played in a sport team. So if I want half played in a sport team, x needs to be at least 5. Okay, greater or equals to 5. You want at least 5, which means 5, 6, 7, 8, 9, 10 is all good. So 5 to 10 students playing a sport team is what I want. I can go menu 55B. Okay, the CDF, because it's a range values. So I want 10 trials, 0.6 success, at least 5. Start from 5 and finish at 10. Okay, finish at 10. Okay, probability is 0.8338. 0.8338. This is a cumulative value from 5, 6, 7, 8, 9, 10. So it's prop 5 plus prop 6 plus prop 7 plus prop 8 plus and 2 prop 10. So is 0.8338. This is normally 1 mark question. Okay, you don't need to do anything. There's no working marks. Just put in calculator. Okay, at least 2 played in a sport team. So find the probability. At least 2 played in a sport team. So it's probability x greater or equals to 2. If, as I said, that's a given question. Okay, if fewer than 4 students sampled play in a sport team. So given x is fewer than 4, so you know is x less than 4. Okay, the question is, what's the intersection between them? What's the intersection? Greater than 2 and less than 4. What's the intersection? 2 and 3. Okay, so it's probability x equals to 2 or 3 over probability of less than 4. Less than 4, I can say that's smaller equals to 3. Or I can keep it as less than 4, but because it's exact values, the next value less than 4 is 3. So I can say 0, 2, 3. So I can divide it. Menu 5B. Use CDF, and I want 10.6. I can use 2 to 3, even though they are the value next to each other. I can still do 2 to 3. And go to the next one, menu 55B. So 10 trials with 0.63. Lower bound is 0, upper bound is 3. Fewer than 4 is only to 3. Okay, so that's the probability. So 0.9694. 9694. Any questions? Okay, if you don't have any questions, this page basically tells us what's a binomial distribution, what is a binomial random variable, and what is a Bernoulli sequence. Also tells us how to find the probability, okay, by when you know this is a binomial. So you have a formula here, but also I have go through how to use calculator for that. Okay, if you go to the next page, it's a very short chapter, so okay, how to graphing it. The next thing I also say is how to graph it. Normally you won't be asked how to graph for it, like never see a question in the exam ask you how to graph for a binomial, but we all talk about different shapes of binomial. Let's have a look. Okay, they are all single dots. You know you can have from 0 to n success, and each success you have a different probability there. So let's have a look. Probability p equals to 0.2. Okay, this is a graph for probability p equals to 0.2, and we do 20 trials. That's the graph, what the graph looks like. So this graph is called a positively skewed. Okay, it's positively skewed. So why positively skewed? Because the highest point is on the left hand side. Okay, it's on the left hand side. So you need to know when the graph will be positively skewed, your p-value needs to be in between 0 to 0.5, which is less than 0.5, in between 0 to 0.5. That's a positively skewed binomial. Well, this one is easy. It's a symmetrical one. Well, symmetrical must have p equals to 0.5. This is like a symmetrical skewed, like middle, okay, in the middle, symmetrical. And the next one is called the negatively skewed, because you can see the highest point is on the right hand side of the middle. So when in this case your p must be greater than 0.5 and less than 1. That will give you negatively skewed. When your p-value is in between that will give you negatively skewed. Okay, so how we can just do one overcast. Well, let's just use the question here. This case, okay, 0.6, and also with 10 trials. Okay, with 10 trials. First of all, let's go to calculator page and go control and right hand side bracket to give this curly bracket. Control and right hand side to give this curly bracket. And then we have how many trials? We have 10 trials, and I want 0 to 10 success, right? I just type 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, that's represent 10 success. And go control VAR, which is a defined arrow. Control VAR. I want to call that as n. Okay, so n trials. I want to say that's n. You can define anything. Okay, anything. So I said that's n. I press enter, so I have defined that. Okay, the next thing I will do is this is the x-axis. Okay, n trials. I want to also do the probability. So the probability will be done by menu 5. Sorry, not that. Menu 5. A. Okay, the PDF. Go to the PDF. Menu 5A PDF. So I know I have 10 trials. I know the successful rate is 0.6, and I'll keep the x value as empty. Okay, as empty. Like I'm not really asking for a particular one. So just press OK for that. It will gives me all the values. Okay, all the values. Just go up. Not there, not that up. Okay, just go copy that down. Copy that down and go control VAR again to define this. Call that a p value. Okay, the probability. So say that's a p value. Just go up to copy that, or even the answer. Copy the answer down and then control VAR p. This is your vertical axis. Okay, that's the vertical value. So now what you do is you go back and you go to the graphing page. You want to graph it. Press menu. And number 3, graph entry edit. And I want to go to the scatter plot. Number 6, 3 and 6. Okay, you have 2 things given here. What I want, x is the n value. X-axis is the n value. Y-axis is the p-value. Okay, and then you press enter. You can see a couple of dots here. Amazing, okay. That's what will happen, but you can see that's not very clear. Okay, that's not the shape. Why? Because I have the y-axis too high. 6 point something, you won't have probability 6 point something. At most maybe 0.8 or something, like for the highest value. So we go menu for 1 to adjust that. My x value, I know it's from 0 to 10, so I put a -1 for this, and I want the 11, give a little bit space, okay, on each side. Well, minimum, let's go for a -0.1. Maximum, well, I can put a 1, but I can see the maximum is not really reaching 1, so I give a 0.8 to see what happens. Okay, 0.8 is still quite high, okay, so see this point, like, maybe it's only 0.4, so I go menu for 1, give a 0.5 here. Okay, that looks much better, like it's center into the middle and looks much better. So I can see there are 10 points, you see there are 10 points, and give probability. By using this graph, I very easily can find the mode. What's the mode in this question? Yeah, so now how you can find the highest? Go menu, number 5, the trees, and number 1, graph trees. Menu 5, 1. So you have to see the center thing at the left hand side. You just keep pressing left, right. No, that's what I... Okay, 6 is the highest point. So my mode is 6. Okay, my mode is 6. And the probability, highest probability is 0.25. It's only 0.25 for the highest one. Well, I can see all the values on this one as well. It's not really that useful, but it's good to see what the graph should look like and what's the probability given each of them. Questions? No questions? No? No? Okay. If there's no questions for this, what I want you to do, this is like, okay, I teach you how to do the, what else? The probability, and now I teach you how to do the mode and also how to see the graph. The next thing we'll talk about is how to do the expect value and the variance. Okay, expect value and variance. What I'm going to do is not directly jump to the formulas. What I want you to do is open a why not, like you can find a back page or something like that. What I'll do is I will give you a x, which is binomially distributed with 3, 1/4. Okay, I hope it's not that hard to calculate. Okay, you know your x value will be 0, 1, 2, 3, 4, right? I want exact values. Okay. Oh, 0, 1, 2, 3. This is x, that's probability x. Okay, I want you first complete this table for me. You can use calculator, anything, just find the full probability for me. Using any method, it's not going to be hard to calculate. Just give me the probability in each box in exact form. Okay, in exact form. Let's see if you have that. Well, this is, if you use calculator, go back, you just copy that down and you change that to a 3 and that changed to, let me see if I can. Just go maybe settings. It can't work. It can't have exact. It's just going to give you decimals. But if you use hand to do it, it should be very easy. Well, my one should be 27 over 64. Give you the same thing. That's exact already.
What if you do it separately and then?
Let me try.
Because I did.
What do you doing here?
I just copy all of them and then use
Convert?
yeah menu to
Fractions. Okay, approx fraction. Menu. Do you find that in the book? The fraction, the convert.
It's just menu to
Menu to 2. No, like if it's already exact, then when they convert, it's definitely exact. Because if not, then it's not going to be very, like, it's not really the real value. But because this one is the exact, so when we convert, it will be the exact. Well, go menu to 2. Hong told me that. Go menu to 2, and it will convert to all the fraction for you. I haven't used this really. Okay, everyone, we have that. And now what I want you to do is find exact value for x. Okay, using the knowledge we have last week, find exact value for x. Okay, x is that, probability is that. How do you find the exact value? You can use calculator, okay? And after you calculate exact value, calculate variance as well. Calculate variance by using this table. Don't look at that like there's no formulas, just do it. Well, variance x is expected x squared minus expected x and then squared. Okay, so we know what is expected x already. Let's find x expected x squared. Well, there, like you will hate me after I go through this, but like there is something calculate easily. But let's just do it. It's a good way to understand. Okay. No, you don't do this method. Like if it comes to exam, this is just showing you a connection between this exercise and the previous chapter. Like what's the connection between them? But like we should know how to calculate expect value and variance for a table, so we can convert a mass function into a table. That's all what we can do so far. So what we have is 27 plus 36 plus 9 over 64 minus, that's a 48 over 60, no, 9 or 16, and that's a 36 or 64. No. 72.
What were you doing? I thought that was 6 over. That's 8 and 7. What is this combination? 8 and 7. And 6 and 8 and 9.
My one's correct.
Yeah.
Okay, everyone. Okay, important thing here. Well, you won't like to do this. Like if there's 10 trials, you're not going to complete 10 values and then do them each individually. So what I want you to practice is, if this is a mass function question, I can always convert that into a table. And the formula I teach you last week is always working. It's just like hard to use or like easy to use. Is that like really practical to use that formula to do it? But if it's a discrete probability question, I can always easily convert that into a table, list out all the values. And by applying this way to it, and then I can always find the expected value, mean, median, mode, like all the values. Doesn't matter if it's a special random variable or it's just a really random variable, like it's a normal random variable. So this method is always working for discrete probability. But because, well, you know it's a special random variable. Because it's special, each individual special random variable will have its own way to calculate the mean and standard deviation. Like say, everything called discrete random variable can use this method to do. But because this is a special one, there will be a lot of special distribution. We only learn binomial in high school, but there will be more. Okay, there will be more. There's quite a lot of them in uni. Maybe discrete, not that many, but continuous, there's a lot of special ones. Each special one will got its own way to calculate the mean and variance and standard deviation. So they got their own formula. So each one got a different formula. So what's the special formula for this binomial random variable is, if you think about this way, I try something 3 times. Each time I have a successful rate of a quarter. How many times do you expect I can success? Let's change the value. I do something 100 times. Each time I have a successful rate a quarter. How many times do you expect you will be successful? 25. So how about if I do it 3 times and you have a quarter successful rate? It's just times them. It's just 3 quarters. As I said, for expect value, you don't round it. Whatever you calculate out, that's your expect value. So it's in long term, like we just times how many times we do it and what's the successful rate. That's how many times we expect it can be successful. Very easy to understand for the binomial. So the expected x for a binomial question is just n times p. That's the special formula for binomial random variable. Okay, so how many times I have done it and what's the successful expectation? Like how many times I expect it to be true, just times the probability. 3. Sorry, what do you mean by by? Oh, you can do bias that. It's like a bias coin, it's fine. A bias coin is fine because all I need is for each trial, I have the same successful rate. That's fine. If it's biased using the bias coin all the way, that's fine. But you can't change coins. Yeah? Okay, the variance. The variance is easy. Variance x equals to np 1 minus p. Is the expect value times the failure rate. Well, there's no reason for it. Just remember that's the formula. It's just expect value times the failure rate, np 1 minus p. Okay, that's the variance. Well, standard deviation is the square root of that, which is easy to do as well. If you go back here, the formula is given already. Have a look. Expect value is here, variance given, standard deviation given. Mode is by graph. I have told you how to do the graph and you can sketch it and find the mode. There's one type of question. Well, I'm not going to do the example here. You can try the example by yourself. But I want to show you an example appearing in exam before. They said x is a normal distribution question and with n, p not given. And it tells you your expect value gives you expect value equals to 7 and the variance is 2.1. Ask you what's n and p. It's a very easy short answer question. I think 1 mark, 2 marks. Give you the variance, give you the expected value, and ask you what's the number of trials and what's the successful rate. What all you need to do is using those two formulas. Okay, using those two formulas. That's the only way we do it. I'm gonna think about what the value should be. Okay, just finish that one, and that's the end of today's class. You finish that, then go bathroom, yeah?
I did.
Here we just simply use those two formulas and sub values in. So the variance divided by the expect value will give you the failure rate. Okay, the variance divided by the expect value will give you the failure rate. After you find the failure rate, you can find the successful rate, and the successful rate will give you the number of trials by using the expect value. So that's what we can do for variance and expect value. Okay, I don't think I can finish the next question, but let's use the next 10 minutes to try that one by yourself, and I'll go through this question with you tomorrow. And also I'm trying to finish the chapter for tomorrow.